In this video, I'd like to show you a new usage of Monte Carlo simulation and Evolver called RiskOptimization. You can see I have the at-risk program already started in Excel, and RiskOptimizer is the new tool. It uses Evolver with its genetic algorithm to try to maximize values that are uncertain. Let's try to see what that means. This model has 5 investments, A, B, C, D, E, which I'm assuming to be completely independent of each other. Current prices in this row. And I'm assuming, yellow, 20% of the total amount we have to invest, 100,000, is going into each of the 5 investments, so that's 20,000 in each. That means at 2450, if you divide 20,000 by 2450, 816 shares of investment A. Similarly, that's how you find the shares for B, C, D, and E. And then sometime in the future, perhaps a month later, we're estimating a projected price for the 5 investments. And we're simply multiplying that projected guess, that projected price, by how many we own to get the current value in that future. Adding up all those future values gives us the total. Subtracting from what we started with gives us the profit. The only thing wrong with this, of course, is, well, first of all, we just assumed 20% in each one. We also assumed independence. But we know these are just guesses. We don't know what the price is going to be in the future. We just made them up. There's no mention of uncertainty here. And you know that that's what Monte Carlo simulation can help us with. So I'm going to click on the spreadsheet down here called Uncertain Estimate, where it's almost exactly the same model. The difference is this $28 is now actually the mean of a normal distribution. Standard deviation is 75 cents, so it's unlikely to be future price higher than $29.50 or lower than $26.50. Standard deviation is 75 cents. Similarly, for investment B, that's a normal distribution. For investment C, I put in a triangular distribution. I like the minimum. I'm pretty darn sure it's higher than that. Maximum, I'm pretty darn sure it's not higher than that. And most likely, I think that's what it's going to be. In this case, I put in 33. I put in a log normal for investment D. It's going to be a little bit skewed, but not much to the right. Mean of $49 with a standard deviation of 7 for the underlying normal distribution. And just to have fun, I put in a uniform distribution for investment E. Anywhere between 110 and 120 is possible. I have no idea what, so I made them all equally likely. And I'm saying I'm certain it's not going to be less than 110 and not going to be more than 120. Now the profit is not a number, it is a distribution. Let's run a quick simulation so you can see what that would be. I'll reduce the number of iterations to maybe 1,000. And at risk is telling us that this is what it thinks the distribution of profits is going to be like. Looks like there's only a 0.6% chance of losing money. Seems to be pretty close to a normal distribution, maybe skewed a little bit to the right, with a mean of just over $7,700, standard deviation of about $3,400. Well, how am I going to choose how to assign my investments? 20%, 20%, 20% is a very even. How should they be assigned to kind of get the best profit when the best is kind of hard to define? The profit is actually a distribution of values. Should I try for the highest mean? Should I try for the highest, say this number here is the 95th percentile. Only 5% values are higher. What do I call a better distribution than this one? Well, we have to decide on that before we go to to RiskOptimizer, but let's take a look. I've set this up to say, right now, that it wants to find a maximum of this cell, H8, which is the profit. And there's many different things we can select. We can have it maximize the mean, perhaps minimize the standard deviation or variance. That might be a good idea. Minimize a certain percentile, or in this case, maximize a percentile. If we leave it at the 20%, we're going to maximize the 20th percentile. If you put a 50%, you'll maximize the median, the 50th percentile. Let's leave it at 20th percentile here. That's basically saying we want the 20th percentile to be the largest we can possibly get. Two distributions for the profit are not equivalent. We'll take the distribution that has the higher 20th percentile. By the way, notice in this range, I'm going to be using the recipe method. And I've said you can have any of the yellow numbers go between 0 and about 0.333. That's basically saying I never want to choose all of one of these investments. I want some diversification. So I'll cap this at 33.3%. I'll never go higher than that. Now I'm going to click on OK, and I'm going to click on Start and describe what's happening right now. Right now, at risk is changing the yellow distribution of investments from 20% to other values, running a Monte Carlo simulation, comparing the two distributions it finds for the profit. Right now, it has done this 36 times, 39 times. Each time it's running a Monte Carlo simulation of 1,000 samples or iterations. And I'm going to stop it. It's up to about 65. That's how many times it's changed the yellow assignment of how I should set my portfolio. I'm up to 80. I think I'll stop. I'm just going to close. Interesting. It says if I want to maximize my 20th percentile, it looks like pretty much maximizing on investment A and E are good ideas, coming very close on B. Don't even buy anything of C, and a little bit of D seems to be what we should do, with a profit of almost $10,000, which was better than what we had started with. Let's do a quick Monte Carlo simulation to find out what that actually looks like. Let's say we change that to 10,000. And it's saying with that distribution of values, and here's something I kind of like, there's no negative possibilities in the simulation, so it doesn't look like we'll lose money with this distribution of values. And you notice it's kind of skewed a bit with a peak way over here. The mean is at 9,900. Mode is at 10,000, so it's saying it's very likely we're going to make this kind of profit with this distribution of assets. Of course, remember now we made up some things about the future. We said this was a uniform distribution and log normal and triangular. And we're assuming these investments are completely independent. But now we have an idea of how we can maximize something about our profit on the way we buy or invest our investments. Let's do one other kind of thought with how to choose the best distribution. What if we're very risk adverse? And by most risk adverse portfolios would have a very small variance or standard deviation. That simply says that what you're going to get is probably very close to the mean. So let's minimize the standard deviation and rerun the simulation. Oops, I'm going to have to stop this real quick. A mistake I make fairly often is that I didn't change the number of iterations down to a smaller amount. If we had left it at 10,000, it simply would have taken a long time to actually complete each of the Monte Carlo simulations for each of the settings it had for the distribution of values in yellow for our investments. So 1,000 simulations at each step is now done 30 different assignments of how we should purchase our investments, our 5 investments. And I think I'll go up to about 80 again, as I did for the previous one, just because I'm curious. I can see our profit is much less. If we want to be risk adverse, have a small standard deviation, apparently it's coming at a cost to us of profit. I notice though that A, C, and E are still prominent parts of our investment, and D is very little. I'm sorry, I think C was missing in our last assessment. Now it's highly invested. Let's do another quick Monte Carlo simulation with more iterations, just to see what we can get out of this particular. There we go. I just want to run the simulation. And with this assignment of the 5 investments, radically different between B and C perhaps, this would be how we'd have the smaller standard deviation. It's only $1,500, which means that we could be a little more certain we were going to reach the median or mean of just under $7,500. We're more than likely not more than $1,500 away from that. And if we're happy with this kind of distribution, the risk-adverse person would be, then that should be the distribution of investments we should make. Now this is a very unrealistic model. I simply wanted to show you how RiskOptimizer allows you to do optimization, just like Solver. This one uses Evolver, an optimization of problems to maximize or minimize some quantity. The problem is that that quantity is uncertain, so it's a distribution. So you have to figure out what about that distribution you're trying to maximize or minimize. How do you decide, when you look at 2 different distributions, which one is the better choice? So in this particular example, we did 2 possibilities. The 20th percentile, whichever is larger is the better distribution, or the standard deviation being smaller is the better distribution. There's no definite answer for that. It depends on what it is you want in your model. What is it that you want to optimize?